All right, this is the third video for the study guide. I'm going to pick up with question number 11. Question number 11, don't those fractions look fabulous? So I'm going to do the first thing. I'm going to look at my denominators 3, 6, and 2. I'm going to pick a least common denominator so I can multiply this whole mess, all little bits, parts, and pieces, times that least common denominator. And in the case of 3, 6, and 2, the LCD is 6. So, yes, I'm going to multiply, but technically what I'm going to do is I'm going to cancel out these denominators first. So 6 divided by 3, right? 6 divided by 3 is just 2. So 2 times 2x is going to be 4x. Minus, because that was what was in the middle of the problem there. I've got 6 divided by 6. Well, that's just going to be, 1. So that's going to be 1 times x plus 4. And I am going to be careful here because of the negative sign here. That will affect both parts there. All right, equals. Half of 6 is going to be 3. 6 divided by 2 is 3. And then 3 times 1 is 3. All right, this made this problem way easier to work with because there's no more fractions anymore. So we got 4x. I'm going to distribute the negative sign. So negative x minus 4 equals 3. Let's see, 4x minus 4 is going to be 3x. I'm going to go ahead and add 4 to both sides. So 3x equals 7. Divide both sides by 3. I'm getting x is equal to 7 over 3. All right, moving on to number 12. Similar kind of problem. I'm still going to deal with my fractions here, my common denominator. So currently the denominators are 2 and 4. So I'm going to work with a common denominator of 4. All right. When in doubt, you can actually just take the two denominators you have, in this case 4 and 2, and multiply them together to get a common denominator, even if it is not the least common denominator. So let's take a look at this. What happens? Well, the 4 and the 4 here will cancel out to just x minus 3 minus 4 divided by 2 is 2. 2 times 1 is 2 there. There's no division here. We're just going to do 4 times 5, which is 20. Let's clean this mess up. So I'm going to get x. Negative 3, negative 2 is negative 5. So that equals 20. Let's go ahead and add 5 to both sides. X is equal to 25. All right. That was part A of question number 12. Let's see what part B has in store for us. All right, so the first thing I tend to try to do with these problems, I recognize I've got a quadratic. It is a trinomial, right? 1, 2, 3 terms. It is already equal to 0. Love all of that. My first thought is, can I factor it? So can I think of two numbers that multiply to negative 8 and add up to positive 4? And the unfortunate truth is no, I can't. So if I can't do that, it's a quadratic formula problem. So x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And the idea here is b and b are the coefficient for x. The a value here and the a value here are the coefficient for x squared. And c, which is sitting right here, is your constant. So now what I want to do is just, and I'm going to say just, but we're just going to simplify this. So let's see, 4 squared is 16. Negative 4 times 1 is negative 4. Negative 4 times negative 8 would be positive 32. And the denominator 2 times 1 is 2. So negative 4 plus or minus the square root. Let's see, 16 plus 32 would be 48 all over 2. So I'm going to give myself a little space here, and off to the side, I'm going to break up 48. So let's see, 4 times 12, that'd be 2 and 2. That's going to be 2 and 6, 2 and 3. So lots of 2's here. Let's see if I can pair them up. Since we're dealing with a square root, I got a pair of 2's here, a pair of 2's here. So, and I ran out of room. Shocking. Let me do a quick shrink on this. Give myself just a little bit more space underneath that. All right. I got enough to write in at least one more line. So negative 4 plus or minus. So square root of 48 is going to be rewritten with a pair of 2's and another pair of 2's. So that's going to be 2 times 2, which is 4. Root 3 all over 2. But there's one more step, of course. And that's that this 2 can divide into that term and that term. So last but not least here, we're going to do negative 4 divided by 2 is negative 2. And then plus or minus 4 root 3 divided by 2 is 2 root 3. And that should be what x is equal to. All right, so we're good with part B here. And now question number 13. Let's take a look at what we got here. It says 2 cups of sugar are needed for 24 cookies. How many cups of sugar are needed to make 54 cookies? I like to make a little note to self here, and I'm going to do sugar over cookies. And in this case, we need 2 cups of sugar to make 24 cookies. And how many cups of sugar? I don't know, but that's going to make us 54 cookies. Okay, so sugar on top here, 2 cups, and 0 cups, or not to say 0, is the unknown amount. And then over cookies, so 24 cookies to make uses 2 cups, and then 54 cookies uses I don't know how much. All right, if we can get the setup going, let's go ahead and cross multiply here. So I'm going to cross 24 times x. Now 2 times 54, I'm just going to write it down as 2 times 54. Because at some point I might want to do some simplification here, so I'm going to leave it as is. I'm going to divide both sides by 24 and 24 there. All right, so what I'm going to do with the 2, the 54, and the 24 is basically look to do any kind of division that I can. And the first thing I notice is 2 can go into 24 12 times. So 2 is gone, 24 gets replaced with a 12. 12 and 54 have a common factor of 54 would be at least 2. Trying to do the math in my head. Oh, it's not, it's 6. That's what it is, 6. So 12 divided by 6 is 2. 54 divided by 6 is 9. Took me a second to get there, but I got there eventually. So 9 over 2 cups. If you're not a huge fan of that answer, which kind of looks weird if you're actually measuring out this recipe, that would be 4.5 cups. All right, 9 over 2, 4.5 cups. And I would accept either of those answers. All right, I'm going to go ahead and cut this video here. That got us through question 11, 12, and 13. I will come back and make some more videos for the other page of your study guide. As always, if you have any questions or concerns, please let me know.